Hello, this is Paul from the Coda community, and it's another unrehearsed tutorial about another very useful Coda trick. So today I want to talk to you about iterator tables. So what are iterator tables? These are basically helper tables that you make with one purpose: to go over some rows of the data in your database and do some operations on them. This comes in handy when you need to do some complex iteration or like walking through the data, and you're running into the current value issue when you cannot access the current value of the outer formula when you're trying to do something with the inner formula. So that's these tables, they serve as a temporary storage for your outer current value items. Well, it's easier to show than just explain like that. So let's head into our first demo. So imagine there's this setup where you have contractors, like three employees, 3 contractors, and there is a list of tasks right here. And each task has one or multiple contractors assigned to it, has some time spent on that task, and you want to know how much in your system you want to split this table in such fashion that each row links only one task to one contractor, so that for like this task where there are 3 contractors, you have 3 separate rows: meet stakeholders for Alex, meet stakeholders for Sarah, and the 3rd row for Matt. And yeah, it's whatever. Let's just imagine that in your system, that's how you want to track it. So here's the table, and your first instinct would be to just like make a button and try to like db tasks formula map, and for each task take each current value contractors formula map, and in the table of db tasks by contractor you want to add row like contractor is current value from the contractors list, so each time a new contractor, and task is, and at this point you cannot really type current value here because this current value, it's an inner current value pointing to a contractor out of, well, the list of contractors for this task. So this current value is overridden and you cannot do this, an action like this. And it's the simplest case where you can run into the current value context issues. Like another common example is that if you want to use a filter somewhere in here, you want to use add or modify rows function, which overrides the current value context, or you want to have some sort of filter, like a check whether you have already saved this row or not. Just for the sake of the show, let me show you what happens when you do that. You see that instead of tasks, the outer current value, we are dumping the inner current value, so the contractor. All right, that's rubbish. Let's get rid of that. So what you should do instead in this case, what I tell you to do, you create a new table. I usually name them with the prefix HLP, which is short for helpers, task dumper. I keep just one row in there. The first is, I rename it to display column and call it, and the value of the display column, just leaving it the same, the HLP task dumper. That's so that I can, like when I have some button in here and I want to reference it elsewhere in the doc, I can reference it by the @ reference. the separate row, but okay, that's not super relevant at the moment. Yeah, and I create a button and I create a column that will hold our current task. So that's where we are going to store our current value, the outer current value. All right, time to code our button. So for db tasks formula map run actions, that's how I'm usually putting this. So I'm doing new lines and all that stuff, but run actions I'm putting on the same line as the formula map, because more often than not I'm using run actions within the formula map. This row, modify rows, current task, current value. So what I'm doing here is that I'm storing the outer current value into the current task cell. So you can see when I just iterate over all the tasks. By the way, let's just, for the sake of completeness, we sort them by date, when, well, the completed date. We want to iterate over them in that specific order. So yeah, this already goes over all the tasks in the order and just puts them in this cell. And yeah, we want to add our rows. So what we do next is that db tasks by contractor, add row. Oh no, current task contractors. We are iterating over each contractor of each task, right? Formula map db tasks by contractors, add row. Task is current task. We can reference the outer current value that we stored into the current task by, well, reading from the current task. It's current task. What else? Contractor is our current value. Hour spent is our current task, hour spent. And completed timestamp is our current task completed. And here you go, it iterates over each of the tasks and adds rows, and then for each of the tasks it iterates over each of the contractors. And here you can see how it dumps the same item, the same tasks separately for Alex, Sarah, Matt. Right? So that's the gist of the iterator table. If you're a pro user, or well, you have a keen eye, you may ask, well, why do it this complicated way? You could just add a button in here on the tasks table itself and just run your action here, like db tasks by contractor, add row. Task would be this row, right? And contractor, or I mean, yeah, this row, contractors, formula map. So yeah, you could tell me just, let's make a button that, let's clear all of this. We can just, yeah, make a button which like adds, iterates over these, like it does totally the same. We don't need the outer current value access. we have this row that points to this row, so the task is the one that we are clicking the button for. And if we want to just do the same, we could quickly make a button that pushes all the DB tasks, all the buttons from here, and we would just end up with totally the same thing, right? So we click the button, it populates. Well, I just forgot to add that. It does totally the same. Why bother creating a separate table? Well, there are a few reasons for that. One of the reasons is that, yeah, it's the simplest case. So if you want to do something more complicated, which we're gonna cover next, is this may not be as easy if you want to do some other calculations. And the second reason is that imagine you will have this document grow like thousands of tasks. You're planning to use it for a large team for so many things over your lifespan. And there is a problem with Coda that all these buttons here, like there is 1,000 rows, it creates 1,000 buttons, and they are stored in your doc as 1,000 separate buttons. And as your doc grows, and perhaps you want to have more buttons like that, doing something else as your doc grows, this inflates your doc very rapidly. I mean, not that rapidly for an average user to be concerned, but like in some of the docs that I've been working on as a consultant for hire, we were running into these limits pretty fast. We were like managing really thousands of rows each month. So yeah, we were running into these limits very quickly. And I discovered that buttons really inflate the doc size. So one of the reasons, one of the solutions to this was to just get rid of these row-specific buttons and re-implement everything as iterator tables. So if we want to cancel classes, like we had a system where we were working with the online classes, not having a separate cancel button on each row, but having some sort of an iterator table where you just check off the classes with a checkbox and then just click here, like cancel all the classes with just one button. So yeah. Okay, hopefully that's clear. Here's a more complicated demo. Let's imagine that in our system we also have this notion of contracts. So for each contractor that we hired, we first hired them for like 10 hours each, and with each of them we agreed that we are paying them this hourly rate, right? And as they were doing some work for us, we discovered that there was more work for them to do, and we asked them to stay with us for 15 hours more, but some of them renegotiated for another hourly rate. So what we need to do is that we don't just need to dump task by contractor here, but let's imagine, and yeah, maybe it's a bit like simulated scenario, but well, what else are you gonna use Coda for if not for some specific and tailored scenarios that you are dealing with in your company life? So let's let's imagine that not only you need to break down tasks by contractor, but you also need to have a separate row tying this task and this contractor to a specific contract. So let's say that like these first tasks, they will all go on specific contracts on these 3 contracts, but when hours are depleted, like there is no more hours on this contract, the rest of the tasks will go on to these contracts, should count towards these contracts. And to make it even more complicated, let's imagine that let's assume that at some point there will be a 2-hour-long task that has to be split in 2, like an hour should go on the contract, like a Matt, let's say Matt has a task somewhere that spans 2 hours. So, and at some point they have 9 hours left and they take up these new tasks. So 1 hour should calculate towards the contract number 3, and another hour should calculate towards the contract number 6. So you can imagine, yeah, it's a more complicated thing, and just creating a button in here like is already going to be more complicated. All right, I haven't rehearsed it, so bear with me for a while. If that's too much for you, thanks for watching, but yeah, bear with me. So we need to assign each task to a contract and split a task in 2 if it spans multiple contracts. So yeah, we have our contract field, and perhaps we don't need a contract, or we can just read it from contract. And just for the simplicity, we don't need the hours span, we can read this from task, right? So basically what we need to dump in here is the task and the contract. Okay, so we have our first task, identify stakeholders. Let's also iterate over current contractor. So it's like, let's say it's Sarah. We need a formula to find a fitting contract, a fitting contract that still has some hours left, right? So current task is, let's split this into as many steps as possible. Also, another benefit of doing this is that you can see how each step, like how everything happens step after step. You can debug it step by step. You can see how the data changes, and it lets you catch issues with your iterative formulas more quickly. Okay, so bear with me. So this task has 2 hours spent. We need to find, so yeah, with contracts, let's look up all the tasks that are tied to this contract. And from the tasks logged to this contract, we want to calculate the sum of total hours tracked. And let's say that has hours left is whether the totals hour tracked is less than hours agreed. Cool. And let's just add some row to see if, so the contract is Sarah, 2 hours spent. Yeah, here's the task, here's the hours tracked, so 2 hours spent out of 10 hours bought. So no hour, still has hours left. Okay, this thing is working. Let's find the contract. Okay, let's just not has hours left, but let's calculate actual hours left. Okay. And to find a suitable contract, we're going to db contracts, filter the contract. Contractor is current contractor, and hours left is more than 0, so that we are filtering out the contracts that have all the hours already used up. And sort by the date of adding the contract, ascending and taking the first one. So this task should go towards the contract CT2, right? And let's imagine that we have, oh yeah, that's a bit more hasty. For debugging, let's imagine that we have already 9 hours spent on this task and there is only 1 hour left, and we want to log this contract towards this. Okay, we need to calculate how much we can actually dump. How much we can actually dump. Yeah, so first we need to know how many hours were already dumped for this task. And we calculate that by task by contractor, filter, task is current task. Yeah, so these are our, if we have the same task and we say hours spent minus 8, right? Hours already dumped is 1. Cool. And what's left to hours still to dump? It's hours spent minus hours already dumped. So let's say we only dumped 1 hour out of 2, so 1 hour dumped, 1 hour still left. How many hours are left in the contract? And the hours that we can dump in this iteration is the minimum of hours still to dump and hours left in contract. So yeah, let's say this task has already like 9 hours spent. Another task is meet stakeholders, which needs 1.5 hours, and we want to dump this for Sarah. So she spent 1.5 hours on this task. It's not recorded yet, so 0 hours already dumped, 1.5 still to dump, 1 hour is left in contract. So we also need to iterate several times until hours still to dump is 0. So how to do that? Let's make a separate action to just dump whatever we can. Task is current task contract is suitable contract. Hours spent is hours we can dump. Yeah, it shouldn't be a formula, that's correct. So that's how we dump this 1 hour, and we still have half an hour left to, and can you see that it already found another suitable contract? So it finished off the contract number 2. So the next time we click this button, these half an hour will go towards contract number 5. That's because we already used up our 10 hours from this contract. So now it calculates towards the new contract. So at least this piece works, right? But now we need to make a loop that will keep doing this until the hours still to dump are not 0. So one way to do this is to make a button cannot click itself, but it can click another button, which then can click the first button. So that's what we gonna do. We make a new button. And in this button, we do the following. If hours still to dump is not 0, is 0, do nothing, no operation. Otherwise, dump what we can and click the loop button. So yeah, if hours still to dump are 0, then do nothing. Otherwise, run actions. So add the row here and click this button. And what this button should do is just gonna click the first button. So this way, if there's still hours to dump, or after each time after it adds a row, it clicks the loop button. And the loop button then back clicks the dump task button. And when the condition here figures out that hours still to dump are 0, or we can just say it's 0, it stops looping because it doesn't call anything else. It performs a no operation, and that's it. So let's see how this goes. We have 1 hour and a half to dump. Yeah, it added 2 rows. It added 1 row towards the contract number 2 and 1 row with the remaining half an hour towards contract number 5. Yeah, so all that's left to do now, we have our current task, we have current contractor, we have all the calculations, we have the loop to check for the next suitable contract, so it dumps the hours that it can, and then if this means the contract is now ended, the suitable contract formula recalculates, it finds for the next suitable contract that still has some hours left, right? So all that's left to do is to set this, this row, modify row. So okay, we are iterating over the tasks. We save the current value as current task. Then for contracts, where we do pretty much the same. Formula map maplan actions, this row, modify rows, we save current value as current contractor, because now we are iterating over contractors, right? And since we already have all our logic in these other two buttons, we just click dump task. So we just click dump task hours. And just like that, we are done. The moment of truth. So yeah, here it goes. Here it dumps the, yeah, I think this should have worked. Yeah, I definitely can see some alt contracts in here. I'm not sure why that happened. No, I'm not leaving you with. I'm not leaving you until I figured out why this happened. Yeah, that's a good case how we can debug that. Okay, prepare team contract. Why did it go on the... Okay, Sarah, and Sarah. Oh yeah, because ours already dumped is not filtering by contractor, so it figured out that if 2 hours were already, like 1.5 hours were already dumped for Alex, no need to dump the same 1.5 hours for Sarah, because the sum is already 1.5. So we need to fix this filter in here. And contractor, current contractor. So yeah, how I figured that out? Well, pretty much by looking at first I saw that the number of rows is too low. Like, then I saw that there are no duplicates in here, which was strange because each task, like there were tasks that had 3 contractors for them and so on. And yeah, the sums were pretty low. So that's how I saw that Sarah only appears once in a while. Figured out what could be wrong. Let's run this again. Okay, now it looks much better. We have meet stakeholders logged for all 3 people. Here we have 2 rows for this 1 hour task. Half of the hour went to the contract number 1 and half of the hour went towards contract number 4. Alex is going to be paid more for the last half of an hour spent on this task. Yeah, now this looks much better. We can see that, yeah, these contracts have no hours left, and these 3 contracts still have some hours left in them. And we have these rows properly attributed to each of the contracts. And that's how we can, like, let's say that for each task some person receives a cut of some, well, you can like imagine anything. And yeah, to make that possible, making just a button in here would be a complete mess. To just try and make a button that would calculate all that, you would basically have to recreate all these columns that we had here, the same loop, all these things, because we don't just have 2 levels of current value nesting, we now have 3 levels because we're iterating over contracts. Yeah, so you imagine, imagine the kind of things I have to deal with in my job as a Coda developer and consultant for hire. Like a shameless plug there. And yeah, and that's where this approach is very useful, to do these kinds of calculations. There is one drawback to this. Perhaps you cannot run automation on this. I mean, if you try to set up automation to click this dumping thing once in like an hour or so, in our setup we have this thing with we are dumping the hours that teachers spent with students, which then go towards the sales, and this way we are deducting hours from sales. So we are running the similar thing in our system that I'm currently working on. And we wanted to do this on a regular basis. I set up an automation on that, and the automation was failing. I have a feeling that Coda cannot run automations on things that are so deeply dependent on recalculating the whole doc. So when you run the automation, it evaluates the doc once, maybe it does some small evaluations as it writes in values, but like here, when you add a row in here, it has to recalculate the sums in here, and then this recalculate the filter in here, and perhaps it's just too much for automation. So automation will most likely be failing for things like that. So this is only useful if you can click this manually, if you're ready to click this manually. But other than that, yeah, that's the trick for you. That's the iterator tables. You can go further. We could and probably should have added a column here, a column here, a boolean, a column here saying it's dumped, so that we don't run over the same tasks again. Like, I think that's something that you can practice on and add yourself. So after a task is dumped, you just check this to true, and then after that you filter this out so that you don't go over the same tasks over and over. Right, so there are some ideas how you can improve that, but the trick is that, and hopefully this was useful for you, and it will solve some of your pains with Coda. Okay, this was Paul from the Coda community. Thank you for watching. Have a nice rest of the day. Bye.